Welcome to Lecture Online, and now let's take a look at weak bases and their associated ionization constants. So just like with acids, a strong base completely ionizes in water. So when we have, for example, sodium hydroxide, when we put that in an aqueous solution, we find out that it completely ionizes into sodium ions and hydroxide ions, 100% or very nearly so. But weak bases only partially ionized. For example, when we take ammonia, which is a weak base, and we dissolve it in water, we have a partial ionization process where some of it turns into the ammonium ion and some of it then with the associated hydroxide ion as well. And we have this is wrong here, this should be case sub B. The ionization constant for bases can then be defined by the concentration of the hydroxide ion times the concentration of the associated or conjugate acid divided by the final concentration of the base. Then if we want to find the pH of the solution, we can find the pOH of the solution by taking minus the log of the final concentration of the hydroxide ion, which comes from right here, final concentration. Then we can find the pH by taking 14 minus the pOH, and if we want to find the percent ionization, we take the concentration of the hydroxide ion divided by the initial concentration of the base times 100%. So it looks very similar than what we do with acids, except the only difference here is that we have the associated ionization constant for the base, and then of course we can calculate the pOH, which then we have to find the pH doing this small step right there. But other than that, it's the very same process. On the next video, we'll show you an example of how to find the final concentration and the percent ionization of a weak base.